The global electric circuit surrounds everything on Earth and connects us to the edge of space. Sprites feed into the ionosphere from below. But from above, the sun also affects the ionosphere, resulting in the vivid displays of the aurora borealis. Auroras are light displays caused by the collision of charged particles streaming from the sun into our atmosphere. There are two types of auroras. The discrete aurora, like the northern and southern lights, have well-defined boundaries that can be seen with the naked eye, and diffuse auroras that spread out over a wide area and are less colorful. 93 million miles away, auroras are born from a landscape of blistering temperatures and violent eruptions. From the surface of the sun, huge volumes of solar material in the form of charged particles are blasted into space. A fleet of satellites monitors this solar activity. Stereo A and Stereo B satellites are making 3D images of the sun and also tracking solar activity. These eyes in the sky paint a detailed picture of the sun and the powerful forces erupting from its surface. The constant stream of charged particles. The solar wind is so violent it would strip away the Earth's atmosphere if it hit our planet directly.
The sun you can think of as a really big, angry hairdryer in a lot of ways. It's constantly blowing hot, energetic wind out in all directions, not just directly towards the Earth, but in all directions. And this hot, energetic, fast-moving particle stream hits straight on with the Earth.
Earth's magnetic field blocks and deflects the solar wind, protecting our planet from a full-on assault. But there is a back door that allows some of the charged particles from the solar wind to reach us. In the Earth's shadow, there is a region in space where charged particles accumulate. These particles, though drastically decreased in number, sneak in through small gaps in Earth's magnetic defenses. The charged particles dash toward Earth and interact with the magnetic field, which deflects and diverts them to the poles. They rain down, forming luminous rings in the sky. The beautiful, vibrant colors of the aurora are visible evidence of the particles' interaction with Earth's second line of defense, the atmosphere.
The aurora are different colors at different altitudes, depending on the gases in the atmosphere that the particles are interacting with. So it's red at higher altitudes, it's oxygen, and then blue and green with oxygen and nitrogen as it gets denser into the atmosphere where the gases get thicker. And then for really, really strong interactions of the particles, energetic particles really penetrating deep into the atmosphere, you may even see like a pinkish purple color down at the bottom where there's more nitrogen.
But sometimes things can go wrong, really wrong. Sometimes the blast of charged particles can be so intense that the auroral ring thickens and vibrates explosively.
There are these periodic events, these coronal mass ejections, where the gas just is incredibly more intense than it normally is, and this charged particle cloud will come out, spiral out towards the Earth, and our magnetic field will respond.
The Earth's magnetic field does a good job of protecting us. The more beautiful the aurora, the more intense the battle at the edge of space. And even satellites high above Earth can fall victim to the power of our sun. In 1989, during a period of intense solar turbulence, induced electric currents caused by the aurora shut down the entire power grid in Quebec, Canada in under 2 minutes. The province's largest city, Montreal, was crippled by power outages. Human activity throughout the region came to a halt for 9 hours. The more recent Halloween storms of 2003 caused hour-long power outages throughout Sweden and impacted satellites and aircraft communications. But the greatest solar storm on record took place in 1859. It created auroras so powerful, they illuminated skies as far south as Hawaii and Panama, while playing havoc with telegraph systems around the planet. A similar storm today could devastate power grids and communication systems and cost billions to repair. In today's wired world, no one is invulnerable.
Solar storms can affect satellite communications in different ways. Performance of your handheld radio, your GPS receiver, your satellite television receiver, your satellite radio receiver, all of these things can be affected by space weather.
We think of electricity as a modern invention, but the electric Earth has always been with us, surrounding our planet and connecting us to the edge of space.